All right. Welcome to our final event for the day. We're going to have a panel with the TypeScript team. So real quick, just to introduce this, myself and Torrey, we're part of a podcast called TalkScript. And
they
so
know.
Hey.
They all listen.
So Torrey and I are going to kind of be leading this thing and asking the TypeScript team questions and doing some fun games. So Torrey, do you want to introduce yourself real quick?
Yeah, I'm Torrey, as you all know, because it says up there. This time it's true. I'm one of the founders of SitePen. I'm a designer, so I don't really do all this code stuff, but I'm going to ask questions about it and I'm just nod and be like, yeah, it makes sense. It's all your questions. It's not my questions, so don't worry.
Cool. Yeah. So Torrey's going to handle all of the hard ones there. So then let's go ahead and introduce the TypeScript team, and we'll have you introduce yourselves.
My name is Mohamed Hegazy, and I'm the engineering manager for TypeScript.
Ryan Cavanaugh, developer at TypeScript. Currently working on the project references stuff that you saw earlier in Anders' demo.
I'm Anders Hejlsberg. You know who I am, so yeah.
I'm Daniel Rosenwasser. I'm the program manager on the team.
Cool. Thank you.
You got to progress the slide. We talked about this, Nick. Oh, you want me to talk about it now? This is smooth operation we got going on here. I said it's all run so smooth today, and then I realized that means someone's got to take the fall and be that guy. So anyway, yeah, like you said, we do a podcast called TalkScript. We went through a few different names, but then I realized that this was the most obvious one, and then I forgot to register the domain. But anyway, you can find us on those podding apps that they use, and yeah, so like I said, we have questions that we got from over the last couple weeks and from you guys today. So I guess we'll just get into the questions because we only have, the timer actually hasn't begun, so that's amazing. Oh yeah, scramble. One job. All right, so I said I didn't have any questions, but I actually have one question, and it's my own. Just because, so this one is just for Anders. Sorry guys, it's why we're all here, let's be honest. I mean, literally. So Anders, you're basically a legend. You've created a programming language. Well, we all know what you've done, right? We all know the resume. What? Things, the scripting. He does the typings. He does types. Lots of types of things he's done. He is the founder of KISS. A lot of people don't know it. Literally, shh, it's a secret. But I want to explore you as a person and not just this technical mind. So some people have a spirit animal, like Facebook said mine's like an armadillo or something. Instead of asking you that question though, what would be your spirit language? Or do you guys just want me to go into the flatten versus smush thing instead? Is that where we're going? Okay, go ahead. You can take either of those questions.
I'm not sure. I'm going to dodge it. I've worked on 4 different languages, and it's sort of like asking you to pick your favorite child, right? I mean, you can't.
You don't have to pick your own. I'm not an armadillo. I say you had to pick your own language, but all right. I see where this is going.
Okay.
He's done all the things. There's no other ones. All right, cool.
No, I don't know. I would pick any one of the functional programming languages. Those are probably the ones that in past or recent years have taught me the most about thinking about the problem differently, because I came through, the very sort of imperative branch of programming, right?
I know what all these words are. Don't stare at me like that.
So pick your favorite functional programming language. If you have not looked at functional programming languages, it's definitely worth, if nothing else, just to get a completely different take and mindset on the problem. And certainly they serve as an inspiration for a lot of stuff we do in TypeScript. So yeah.
Go ahead, Nick.
Cool. Yeah. Thank you.
He has a real question.
I do have a real question. So if we name who asked these questions, then that means that we know who did it. If we don't, then we either don't know or there were several people who asked very similar questions. So,
Or I forgot to write it down.
Torrey forgot to write them down. So this one's for the whole team. How does the TypeScript team prioritize new features and requests that come in from GitHub?
So I would say that most of our features are prioritized just by what the community demands in general, right? So for instance, it sounds a little bit funny, but what we typically do on GitHub is we sort by emoji, like actual reactions. And so sometimes people will like joke around and they'll like throw up the party balloons emoji or whatever. But we actually try to get a sense of like what the highest demanded feature is, and based on that, we'll actually say, you know, based on things that we've been able to accomplish in past releases, is anything more feasible? Is anything easier? What sorts of things are happening in the JavaScript community to like motivate that feedback in general?
And I would just add, as the JavaScript ecosystem moves, as it does very, very frequently, the kinds of type system mechanics we need really change as well. So like partial, we really need because of React, right? That type wasn't really necessary until you had set state and other kinds of patterns like that. So if the JavaScript ecosystem moves onto patterns that do other stuff, we're going to need to make sure that the type system can express those things. You saw a similar thing with Vue. Vue uses this in a very interesting way, and we had to add some support to how we infer this in certain cases so that you could get a better typing experience for Vue. And just going back all the way to the beginning, I mean, I think generics were because of jQuery, right? And like, odd to say, but yeah.
Yeah, just to add on to that, it is often also exploratory things where, for instance, I'll say, you know, what is it that we need to do to support other frameworks and libraries and whatnot? And so, for instance, key of and index access types were pretty heavily inspired by the way that people had been using things like Ember and Backbone and things along those lines. And it actually ended up becoming more general, which was kind of the beautiful part of it.
Nice. Thank you. Thanks for letting us know how to game the system, too, with emoji.
What's your favorite? What's your spirit emoji?
Pile of poop.
It was this morning, I bet.
So when is, if you can talk about it, when is TypeScript 3.0 planned? And have you maybe considered switching to version numbers that are a little bit more compliant with semantic versioning?
I promise not to go on a Semver rant.
Well,
Well, you can rant.
I mean,
we
so
have
you
time.
can sort of do the math, right? I mean, we're at 2.8 and we ship every couple of months or 3, so it's gonna be this year.
You could go 2.10
sure.
though.
Yeah, yeah.
You could go
We
2.11.
We could.
Apparently, you
never
don't know how to
You
use the
never know.
numbers right, and they're
We
all
could-
calling you out on Twitter.
We could even skip 2.9. We skipped 1.9, so
should.
you know, I mean, it's
Apple
it's
just
gonna
skipped
be-
9,
that's-
8, and 10.
The suspense is going to be killing you. Yes.
Doesn't Microsoft often skip 9? There was like Windows 8 and then Windows 10.
They skipped 13.
Makes sense. So, are there things that are on? Well, wait. Actually, I would like to know why you don't want to go on that rant.
So in our type system, literally anything we do is a potentially breaking change. Like adding an optional property to libdts is a breaking change because you could have declared that type somewhere else with a conflicting type, and now you have a type error, right? So if we strictly thought about like semver bump as any time that we could introduce a new type error into your code, you know, we could still release, you know, a new semver every month, but we feel like that's not very communicative. I think in practice what people do with semver is still sentimental versioning, but dressed up with a little bit of fake formality, where if you follow me on Twitter, I had this a few days ago, it's like a major version is I broke you on purpose, a minor version is if I broke you, it's your fault, and a patched version is I don't think this breaks anyone. We kind of have the same model, except we never break anyone on purpose without like either a flag to opt it out of or a really high confidence that we think that we're correctly breaking your code. And we've had bugs where it's like we accidentally didn't check an expression at all. And you know, it's technically a breaking change to start checking that expression, but we feel like, if you were accidentally multiplying two strings, but like it was in an extends clause, so we forgot to check it, like, that's just weird to put in a breaking change note and be like, be ready to upgrade your code because, now we're actually checking this correctly. It's like, it's bug fixes, and then, we've had breaking changes in the past before first release where like literally every single class in the world got broken by one TypeScript release internally. That'd be like what Assembler would look like for us, and we just try to not ever do that.
Don't tell the higher ups this, because they might come up with an idea for a services model to fix all the things and encourage you to break them all. So
No, but we're never going to do that. I mean, it's just not going to happen. So
I think decorators, if they change the syntax, would be
but
like
we're still going to keep a switch with the old behavior, right?
classic
I mean, we
decorators,
can't.
we're in good hands. Speaking of the TC39, are there things on the TC39 roadmap that might impact features currently supported in TypeScript?
Decorators.
Do you see my reading skills, people? That came from Twitter, someone, I don't know.
Our policy has been that once a feature reaches stage 3 on TC39 on the standards track, we're sure that it's not going to change significantly, and then we pull it in. That's what we've been doing with the features, and once a release has been standardized or close to standardization, we have a new target flag for TypeScript for the compiler release. I think we keep an eye on all the features that are like down the pipeline. We try to interact with them as much as possible. So Big Int is just made it to stage 3, which means it's something that we're going to be implementing soon. And then we're keeping an eye on the decorators, private state, proposals, and so on and so forth. But yeah.
And it's worth also mentioning that like we participate actively in TC39. We're in close contact with our TC39 representative, Brian, who's actually in the front here. Say hi, Brian.
Hello.
That's good.
He sat here for a reason. He knew this was, you guys planned this.
Yeah, we planned this. So, I mean, we talk to him, and he tells us if we're doing stuff bad, but usually we don't, so I don't think it's ever been a problem.
All right, cool. So the next question comes from Jordy B. from Seattle. And he asks, when TC39 takes a totally different direction, for example, the pound sign versus a private keyword, is TypeScript planning on some kind of alignment there? Or can you talk about what happens in that scenario?
Well, I think I alluded to it just before. It's to us, it is super important not to break people's code, and we full well know that nothing ever goes away. So even if there's pound privates or whatever they might look like, there will still be the kinds of privates that we have currently, and we might potentially choose over time to put them under a switch or whatever, but that is going to happen in an orderly fashion. Because people don't like it when you break their code in the name of purity. I mean, it's just not productive for anybody. So we don't generally go there.
So we got a few questions relating to Babel, and I guess the general theme was like, what's the plan for Webpack and TypeScript, and what does it mean for the transpiler part of TSC compile? It's kind of a lot of just basically that same question in various different ways.
I can give you a little bit of kind of overview of what we've done. So Babel has been growing in popularity, and then one of the things that we got is that people have been having a hard time fiddling with Babel once they get their setup working. So once they get it working, they do not want to touch it. They'd like to try TypeScript. Maybe they want to plug it in, but they want an easier way of doing that. So the thing that we've done is we took the TypeScript parser and we implemented like the same syntax and parsing logic in the Babel parser, and then we created a plugin for Babel that will strip the types and will emit some of the TypeScript specific features like enums, for example. This way it means that you can have your TypeScript running as a background as a type checker still, without an emit. So we have a flag that's called no emit. So you can run that, and then you can leave Babel to do all your transformation. Obviously, there are things that doesn't work, like if you do not run TypeScript at all in the background, you will not get your errors. You will only get your transformation, which is fine. So, and that doesn't change anything about the TypeScript compilation today. But that's like we're trying to make it easier for people to try TypeScript and use it wherever their setup is.
Right. I mean, I think the bottom line is it's just hard to reconfigure your build system. You all saw that talk from Devin, and nobody wants to touch your build files once it's working, right? If it ain't broke, don't fix it, right? So we really just wanted people to be able to just try TypeScript out and not have to remove the tools they enjoy using or rethink about how they do a build in general. And so now, you don't get your type checking in the same build step unless you configure that a little bit, but it's just so much easier to get up and running with TypeScript if you've got another configuration. So.
All these questions, I didn't know developers were so terrified of you guys breaking their code, but it feels like everything in here, they're very worried. Have you guys done that in the past on purpose, and they're feeling the pain?
I've done it
Is
on
it the
purpose.
IE effect? They're like, hey, I remember IE6.
All the breaks were caused by Daniel, by the way.
It's all
That's
his
a true
fault.
story.
We need someone to blame.
It's okay.
So the next question comes from Steve O from New York City. And he just wants to ask, for each person on the panel, is there a feature that you once wanted in TypeScript, but now you think should never be implemented, or something that you regret implementing?
It's getting darker and darker in these questions.
How much time do you have?
Surprisingly, a lot. Wait, did you want to know how much time you had because you need to think, or what? Or you had like a lot to say? Because it kind of seemed like you were leaning into I have a lot to say, but then it might just be the thinking thing.
It's like const enums, namespaces, illigen, maybe. But that's the problem is that's debatable. Like,
Yeah.
Let's do this. Line up on sides. Who wants to debate?
these are mine,
Let's go.
I guess. What else?
These things made sense at the time.
It makes sense at the time. Yeah, no, they totally did. I mean, if we hadn't done namespaces, there would have been no way. I mean, there was no modules at the time. And we've since de-emphasized that, but it's like, there is no, I often say, like, show me the perfect programming language and I'll show you a programming language with no users. Because it's only then do you get to fix all of these things that bother you. But once you have the curse of adoption, right, you can't go break it. And so you're going to have to live with, and you're just going to have to try to make as few mistakes as you can, but you're going to make some.
So you can't pick your favorite child, but you can pick your worst adopted one, is what I'm hearing. Just have red hair.
If you're looking for a theme, I think it's all the features that are really awesome but block single file compilation. Yeah.
He's holding his mouth. He's like, I'm not talking. Like,
No,
it's
yeah.
like, I'm not going
Literally,
on. I have
he
a
just
lot of
listed
things
the
to say.
3 things that block single file translation.
So we got a lot of questions about this project. I don't know if you guys heard of it. It's called like Flow. A lot of those questions. Weirdly, not a single smush or flatten question. Nothing. I'm like, I can't believe it because I just wanted to ask that. Just because, why not? But a lot of questions about Flow, and I guess if you guys have any interactions with the Flow team, and if there's been any kind of back and forth, and why you guys are clearly better, or anything like that. I ad-libbed some of that question. I'm not going to tell you which part.
I'd say, I think the initial interactions went between, the Flow team and Mohamed and Anders here. They can speak more to that. I think more recently, there are certain members of the team, like Sam Goldman, who has reached out and, said, hey, this certain thing that you have working in the language seems really nice. Have you seen any problems with it with your users? And, we can have a friendly discussion about the merits of certain design decisions that each of us make. I think it's really cool to see just, some of the thinking of that they're doing. For instance, I think opaque types are a really cool feature as well. It's something that, I've had a familiarity with from other languages, from like the OCaml family of languages and whatnot. But we've prioritized other certain things to try to make. I think as of recent, it's about making TypeScript as accessible as possible to a broader set of users. So certain features like that, I'd love to have it in the near future. But first, we have some other stuff on our backlog that we want to take care of.
Thank you. So the next question comes from Laurent L. from France. And the question is, do you plan to target WebAssembly or any other intermediate language?
WebAssembly.
We're trying to get a rise here. You guys are dodging very, very well.
Okay, so, yeah, I'll take that question. My favorite question. I got asked this question like 3 times at the last event I went to. It's like, let me first categorically state that WebAssembly is the most aptly named technology on the internet today. It's remarkable how everyone thinks that it's going to solve every problem known to mankind. It is also the most misunderstood technology, and I'll explain it. So I've sort of come to explain it this way, because people don't really get what it is. And so imagine that you had a 6502 emulator built into your browser, okay? Or pick your favorite CPU architecture. It doesn't really matter what it is, but it's a low-level machine. It has memory, and it can execute code, right? Machine code. And you can put stuff into its memory by poking numbers in there, and then you can tell it to go at a certain address, and then it goes for a while, and then it comes back, and then you can take stuff out of its memory. That's WebAssembly, right there. I just described it to you. Now, what can I do with something like that? Well, if I have a computational problem that is computationally intensive and allows me to easily just put blobs of data into its memory and take it out again, like, I don't know, like doing some blur on a bitmap or some CRC on some big blob of data or something like that, sure, it can go faster than JavaScript. It could also be useful for game engines, because game engines, in a sense, are just what I described, right? They manipulate a bitmap that then gets shown on the screen, and then they do the next frame, and that gets shown on the screen, and you take some input, but it's really just a big binary blob that you then put up on the screen, right? And so for bitmap games like that, sure, it's useful. Now, does it even make sense to say, will TypeScript target WebAssembly? I mean, it's like, I don't even know where to begin to answer that question, because if we did, well, we would have to, first of all, ahead of time compile to machine code, and then we would have to package a garbage collector, and then we would have to put all of that into some binary that we would then put into the browser, so you could run a JavaScript engine emulated within your JavaScript engine.
So what I hear is it's coming soon.
That's right.
You seem to have how this worked out.
That's not likely to happen. Now, that said, you can use it to run like legacy code or whatever if you have this piece of code that is written in C and you just want to run it in a sandbox and you can arrange for it to run inside the browser, you can do cool things. You can do surprising things with this stuff. But it's important to understand, like, we're talking at a completely different abstraction level here, and sometimes it doesn't even make sense to ask the question.
I bet he wishes we would have left his name off of that one.
I would also say 90% of the people who are excited about WebAssembly should probably be excited about binary AST instead. Just in terms of like upfront load times and more immediate execution, reduced zip file size, that kind of thing.
So you're going to do that in the TypeScript 2 next? Is that what I hear?
I think Brian's going to push for it, right, Brian?
Nope.
Yeah. He's our 7th panelist over here.
All right, so I got one more question, and this one is because we're at the first ever TypeScript-specific conference, and I'm feeling pretty inspired, and I'm sure everybody here is feeling pretty inspired. I'm wondering if you are as well. Is there something that's inspired you coming out of this conference? More specifically, I'm asking if the error messages in TypeScript will be in haiku form from now on.
I knew that was going to haiku somehow, some way. I was like, where's he going with this? It's going to a haiku, though.
So we get asked this a lot, and we're really thinking more iambic pentameter if we can get that. I don't know about haiku form, but I originally worked on the -- pretty flag, and thank you. And actually that was slated.
Pretty boy.
Yeah.
No, that makes sense.
And so, I think I had a prototype of it. Nothing happened with it for a while, and then like there was this Elm blog post about like, hey, look at our error messages, and so then the pull request eventually went out. I think the developer experience is so important there, and I really want to, not just beef up the editor experience, but also the command line experience a little bit more. That said, always feel free to send us a pull request if you think like this error message is incomprehensible. Like, we want to improve that, right? So if you ever think like I could do better, do it. Like, really, we take pull requests on that stuff, yeah. And we freely accept pull requests, or sometimes the team member will immediately feel inspired to just do that stuff. So yeah, feel encouraged.
You hear that, Nick? That's your opening to bring in the haikus. He's saying, like, listen, I'm not saying you can do it, but if you put a pull request in, it might happen.
The next DDoS attack on GitHub will just be adding emoji to that pull request. So.
That's a great idea. Okay, so we're going to play a game called Truthy Falsy. So basically the way it works is I have three facts, or three truthies, well, two truthies and a falsy, and I'm going to name them all. I'm going to read them out, and then we're going to go down the panel, and you tell me which one you think is the falsy. And maybe we'll do some audience participation and ask you guys as well, and then see where we're at, okay? So here we go. This is the first one. So these are the theme on this one is errors in code. I thought it was appropriate given the type checking and all of the problems and the terror that everyone feels. So I thought I'd do some real world terror of things that actually happen, maybe. So in 2007, a special election in Arkansas had to be halted and rescheduled after it was discovered that after thousands of votes were cast, every machine had exactly 99 votes, and the central database they were supposed to upload the vote totals to after every 100 votes were cast had 0 votes. So they halted it, rescheduled it, and it turned out after investigation that the voting machines actually had the wrong IP address for the server, and it was coded in a way that it would wait for a response from the server before saving the totals, and it would verify that with the hash that it would go, that it was what it sent was right, and the server would respond, and it was waiting for that, and then it was going to reset the counter, go back to 0, save the stuff, and keep counting. But of course, it was at 99, and every new vote just became another trigger for a server that didn't exist, so they had to halt that, and they had to reschedule it. Okay, that's number one. Number two. At the 2010 Wimbledon Championships, a record-breaking tennis match lasted 11 hours and 5 minutes and played out over 3 consecutive days. On the second day, the scoreboard went to 47-47 and then just stopped adding scores. This was because the software was hard-coded to only go up to 47-47. A program had to work late into the night to create a hotfix, and the fix worked the next day. But if the game had gone on any longer and someone had broken 100, it would have stopped working. Okay, a third one. In 1965, Soviet cosmonaut Alexei Leonov, I have this. I'm not going to say it though. Became the first person to perform a spacewalk. Things went smoothly until he tried to get back into the ship and realized he couldn't fit back inside. Despite a lot of testing, nobody had realized that the suit would bloat due to the lack of atmospheric pressure and the oxygen being pumped into it. His only option was to go headfirst into the airlock, bleed out some of the oxygen, try to slim the suit down without becoming hypoxic and passing out and dying in space. So, what one do you think is the falsy? 2 of those are true.
I don't know which is more concerning, but the Russian space thing.
Okay.
I agree. I'm going to say number 2, the Wimbledon.
Okay.
Russians in space.
All right. What does the audience think? If you think it's the election one, clap. All right. If you think it's the Wimbledon championship, clap. All right. If you think it's the cosmonaut with the great name, clap. All right. So I will go in reverse order here. In 1965, the Soviet cosmonaut almost got stuck in space and died is actually true. Anders is like, yeah, I know. I remember that. Just like, yeah, no. Yeah, that's the thing, guys. So he, yeah. No, you didn't. You saw it on TV 20 years later when they finally told you about it. You only saw the good part of that spacewalk. The good old CCCP on his helmet. Okay, So number 2, or I'm sorry, we'll go up to number 1. In 2007, the special election in Arkansas to be halted is actually the falsie. I just made that one up, but man, that sounds plausible. And so the Wimbledon Championship, that actually happened. I couldn't have found a better one that would be true because it sounds unbelievable. But the reason that it went so long and so high is because normally in tennis, if you draw, you just draw. But apparently in this whatever contest, I've never heard of it, if you draw, you just have to keep playing. And so they just kept going for 3 days. So good time. I think you all lost though. and that, yes.
That explains why we designed type systems.
Yes. So let's just be a lesson. Even if you think you've tested stuff, you might get stuck in space. I think. Is that the lesson? Is this the takeaway here?
Probably, yeah.
Okay. Cool. That's truthy falsy. We can go back to the questions now.
Thank you, Torrey. All right. So this next question comes from Paul C. from England. And he asks, what is your
I
favorite...
thought we were leaving names off.
Oh. What is your favorite feature of the language? Pretty sure mine will be conditional typing.
I think mine would probably be Kiev, just because that was the start of, well, maybe it's string literal types. I don't know. Oh, that's hard.
Those are good.
But it really started changing the way we thought about, how you do metaprogramming in a typed language, right? It's sort of a novel idea, and so with just this basic concept, you can start building a lot of really interesting things in the type system itself. So
I'm going to have to say union types. I think that's like the most profound of all of them, because that is like the deep enabler for things like non-nullable types. Couldn't have done it without it. Control flow type analysis, couldn't have done it without it. Discriminated union types.
yeah, yours is right. Mine's not as good.
That's why he's in the middle chair.
Barring those two, I'd have to say just structural typing in general. Anytime I go to write C# now, I'm like, oh, I just want a little anonymous structural type over here, and then C# is like, what are you trying to do, sir? I'm like, oh, right, wrong language.
It's not really the language, but it's part of the tool set is how we handle the add types distribution and sucking them in. It just makes the whole thing works out. And
Yeah, good job on that, Ryan.
Yeah, Ryan worked on add types, so that's all his work. So yeah, good stuff.
Okay.
I'm still in truthy falsy. I forgot to scroll.
So how does the TypeScript team feel about allowing developers to write custom extensions to the compiler?
Were you saying boo earns?
I'll take
Did
a
I hear
crack
boo
at it.
earns?
I think, generally speaking, it's something that is like unless you can find a very constrained API surface point to allow that, you run the big danger of painting yourself into the corner instantaneously. Like, so let's say that we allowed you to just sort of arbitrarily inject yourself into the type checking process. Well, then by the time we ship the next version of the compiler, what do we do now? Break all the extensions, or do we like validate them all? And the problem is they may have made assumptions that are incorrect or that we want to mess with, because in the name of improving architecture or what have you. So it's both good and bad to have API extension models that have very, very broad surface area, and I am definitely weary of that, because the problem number two is like now every program becomes its own programming language, right? Because I wrote this with that extension and that extension and that, but especially not that extension, because that one does weird things. And but that's the one that I needed, and now I can't mix the two because it's like we're speaking different dialects, right? That's not a good thing. Now that said, there are parts of the compiler, like the emitter, for example, that are already done in phases. like where we lower from ECMAScript 6 to ECMAScript 5, or from JSX first, and then from 6 to 5, and then down to, final output, and I could imagine, like, say, a minifier phase there that would plug into that, and, with the caveat that if the AST changes, you got to update that one, but it's sort of a known point. Do you know what I mean? And you could sort of reason about what might the effects of that be.
Sure. Nobody tell him about NPM.
But other than that, I'm generally weary of this notion of extensible languages. Yeah.
Okay. Do you think optional typing should be the default for all languages?
Well, if you think about a language that has to compile to actual opcodes like C or C++ or any other really low-level language, like what would it even mean? It's very confusing. I think it's a great concept, but something that we can get away with is we just submit to the JavaScript that you wrote, so it's very easy for us. But I think what would optionally typed C# even look like?
Well,
you could imagine that everything was possibly dynamic, but
it's sort of a precondition for even being able to ask that question is that you presuppose a runtime that prescribes defined semantics for any possible syntactic construct, right? That is deemed a valid syntactic construct. If you don't have that, then you can't talk about about optional typing, because that means parts of your program are not typed, and that means that you can't reason about what code to generate, so now it's useless, right? So it turns out that optional typing is useful in VMs like JavaScript that already have defined, but not necessarily desired, behavior for all programs, right? And our job is just to tease out the undesirables, if you will, right? But it's a very different point to come from, than your sort of classic, I have a type system for code generation's sake, that most languages come from.
Yeah, I was just looking at one that asked about why, or maybe, do you think you could make your error messages friendlier? And I'm thinking, are they mean right now? And then I know we talked about it a little bit, and they got the pretty flag, but maybe the pretty boy can take that and say what he wants to do.
Maybe if it was in haiku form, it would sound nicer.
Well, thank you.
I never thought about that. So
Nick wrote that question, to be real. He tweeted that at us. He really wants this haiku thing, guys.
Yes. We'll give it a shot.
They're not very friendly right now.
We'll try it. Maybe 3.0. Maybe. Yes.
When's that coming again? We got that one. Okay.
This year.
Well, if I had to speak to error messages, I think there's two broad categories when I think of bad error messages. One is way too deep, where this top line doesn't tell you anything and you have to drill all the way in, and then it doesn't fit into your console anymore. And I think that's one where it's really unclear what to do, because if we don't give you that entire stack, it's really difficult for you to reconstruct. Why are you talking about this type that wasn't there? Mm-hmm. And then there are other ones that are just straight up inscrutable, even if they're one line. And that's kind of an easier place to target. When we design error messages, I say design in big air quotes, because literally it's we'll be sitting around waiting for our pizzas at lunch, and it's what do you think that error message should sound like? And we just kind of bat type system words back and forth until something seems to parse, and then that'll go up, and then later someone will be like, what are you doing? And it'd be great if we could if you can think of a better way to phrase an error message again,
haiku forms.
Yeah.
You got this.
Typically, Mohamed will, loop me in on a PR and say, what do you think this error message should be? Because right now it sounds weird. And I'll just throw out a slightly better one, maybe. I hope. Maybe I'm helpful here. But, it's naming things is hard. So is, coming up with a general but helpful error message.
And I think often too, sometimes it's not so much the error message, but also trying to add suggestions to the error messages. One of the things we added, for example, is we actually ended up with what Nathan's own implementation of Levenstein difference for identifiers, so we can show what is, you spelled this identifier wrong. What did you probably mean, right? And then search our simple tables, run them through this Levenstein algorithm, out pops, what you probably meant, right? And suggest that. And those are the ones that are really helpful, right? I mean, so often it's not just the message, but it's more like trying to provide more contextual help.
That is more helpful than maybe you have a typo. So
We should just put that at the end of all of their messages.
shit.
Have you checked for typos?
Yeah. You just say, well, now Stack Overflow goes under. Now what? All those people are out of jobs. How are you going to feel about that? Where am I going to comment on random things I don't know anything about now? Quora. Yahoo Answers. Got it. Never mind. Reddit.
So this next question comes from Twitter. Which type-related features would you most like to add that are in tension with the superset of JavaScript requirement?
That's a tough one.
Wait, what was that again, sir?
Oh, we could like automatically prefix class members with this dot if we didn't have to be a superset. People would love that. Yeah.
That's probably the one that, well, I mean, it's like if you're coming from Java or C#, like people immediately go, why do I have to say this dot all the time, you know? But we're not going to go there, really, by the way. So this is entirely a hypothetical, right? I mean, we're pretty committed to staying true to the ECMAScript spec, and then innovating in the type system. That's our purview, you know. So
I think that's why TypeScript has become popular, because of that promise. Yeah.
Yeah, so this question came from here, and I think it's a good one. So, Anders, you skipped over the OOP versus FP slide. Do you want to go over those?
well, I'll have to
acronyms?
wait for the next TSConf, but yeah.
Just briefly. It actually says briefly touch on it.
Sure. I think what I wanted to talk about there was sort of the fact that a lot of people say, TypeScript, I don't want TypeScript. It's like it turns JavaScript into Java or C# with all these classes and whatever, which actually has nothing to do with TypeScript, right? I mean, that's ECMAScript. But JavaScript now is both an object-oriented and a functional programming language, but it was actually primarily a functional programming language. And there is a part of the TypeScript type system, too, that is much more functional than OOPI, and that's where I wanted to go with some examples that demonstrates either an object hierarchy versus using discriminated unions, and how when you're writing in the functional style, you get true separation of code and data. You know, like one of the things that a lot of people find pedagogical about object-oriented programming is the commingling of code and data, and the fact that I can think about a single concept and have all the data and all the code, but in reality, it creates a lot of friction and dissonance too. Like if you want to try to save an instance of a class as JSON, well, all my methods go away. So, well, I suppose I have to put it into some data transfer objects and then save those. And then when I read it back, then I have to put them back into classes, and I got to write these serializers and deserializers. And I mean, and it's just a bunch of stuff, right, that you got to write that doesn't really have anything to do with your problem. And another one is just like I mean, if you're attaching code to your objects, or when you're attaching methods to your object, if someone gives you an object hierarchy, but it doesn't have the method on the object that you wanted, now you got to write that as a standalone function, and then you got to like do instance of checks in order to check which instance I have here, and you get all these code smells, and it's like it just doesn't feel right. Do you know what I mean? And there's a functional way of doing these things instead, where it's just functions that take arguments, and if you want to like branch on some of it, you write a switch statement, right? And with discriminated unions now, we can narrow the types appropriately. We can do exhaustiveness checking, because if you handle all the cases, it goes to never at the bottom, and you can assert that. And so there's a whole bunch of things. And that's actually the way that the TypeScript compiler is written internally. And it turns out that it performs a heck of a lot better, because all the polymorphism, in a sense, goes away. Because when you're calling functions, the VM knows exactly who you're calling. Hey, you're calling that function. I can inline that function. I can see where you're going. When you're writing object-oriented code, you're always going through a function pointer. Like every method is an indirection, right? And you never actually know where you're going to go. And that makes it really hard for VMs to optimize. And so you're paying all this overhead, you know, that you otherwise wouldn't have. And so So it's well worth researching. You know, and certainly, like, you could take a look at the source code for the compiler. Like, it's a big piece of source code, obviously, but if you're looking at in principle, you know, yeah, we end up with some big functions. The type checker is like a 26,000 line function that has like probably 1,000 functions in it at least, right? And a whole bunch of state and whatever, but it works. It works really well.
And I think you've seen too, like immutability is really making a big comeback, and immutability are often frequently at odds, and that leads to a lot of problems.
Yeah, and that's indeed true of all our internal data structures too. In the compiler, it's all written as persistent data structures. So our ASTs are after we parse and generate an AST, we never mutate the AST, and that means we can share it amongst multiple instances of the type checker. And also, we actually never try to incrementally update state. So when you're sitting in the editor and you're typing, every time you type a character, we blow away the entire world. We forget everything. And then we reconstitute it, but we're very lazy, and we only reconstitute just enough information, and we reuse as much of the old data structures as we can, but it's done in a very functional manner, and it has some beautiful characteristics, because you're never actually reasoning about strange state effects, right? You're always coming from a known point of nothing, and then you're building it up. And that means you're actually always taking the same code path to get there, as opposed to, well, first I set the first name to this, and then I changed the last name to that, and then I did this, and then I did that, and then like all these state transitions, and then something was wrong in the state machine that you had built to incrementally update stuff, right? And you can never reproduce it again, and and you just get this flakiness, right? And going the other way, it's harder because you got to design your data structures right. But once you get it, it's rock solid, and that's actually an interesting learning.
That was a big lesson from the compiler switch.
Yeah, it was.
Cool. Thank you. So we are out of time, but they're asking me to stall while they get everything set up. So,
We'll take some more questions.
excellent. Everyone want more questions? All right. So I have another one here. Does the new Composite Project feature offer additional benefits if all my TypeScript code is in one big repo?
Yeah, absolutely. I think the two main things that I'm looking at as the benefits from Composite Projects are the performance improvements. So you saw that with Anders' demo. The best case scenario for us, like the compile times are going to go from, like, at least in my machine, like 2.5 minutes to like 11 seconds for a inner loop. But the other thing I've noticed as I've been restructuring the TypeScript repo to use this feature is that the improvements in your ability to describe your layering have really gone up. The diagram that you saw on the slide there is like not even accurate anymore. It's much worse than you can imagine in the original compilation. And I was telling some people between breaks that like the compilations that we had were like almost ill-defined in terms of their ordering in TypeScript, which is harrowing. I don't like to think about the fact that TSC.js and TypeScript services.js had different code ordering in their outputs. Yeah, so, but really it's about like you can detect circularities between modules if you didn't intend that. You can make sure that you're not accidentally referencing from modules that you didn't intend to. Like we had some helper functions in like utils that were referencing the parser, and like you don't want that, right? The utils file should not have to refer to the parser in the scanner. So it was a good exercise to kind of move things around and make sure like, okay, the utils file is just a bunch of utils. And now you have like parser utils, which has like parser related utilities. So I think even when I started out this project, I thought, oh, this is going to be for really big repos, and everyone else can just continue with their little standalone projects. And I've come around and decided, like, if I'm writing my own code, I'm going to be using this feature just, for 5,000 or 10,000 line projects, if not smaller, because the ability to enforce that layering in a more structured way is going to be great. Yeah. This is something that VS Code, like their code base, enforces layering through some like lint rules that say, well, code in this folder can't refer to code in this folder because it's all one big compilation, so they have to have some extra step to say, no, like the clipboard should not reference into the TypeScript language service plugin, right? Which, that's awkward. It'd be easier. It'd be better if there's like a more native way to express those dependencies.
Yeah, I just want to add, like, it quickly became clear that almost any project organizational structure that you try, to create beyond just a simple source folder benefits from this. Because, as soon as you write a tests folder, well, your tests implicitly have this, or explicitly have this dependency on your source. So now, in reality, you have these two projects, each one that can be built, one that can be built on its own, and one that has to kind of be built with the other in mind, right? And so, that's one scenario. Another is maybe you've tried to have a full stack TypeScript application. So you have client and server, but then you have a shared, set of validators between the two of them. And then you realize, well, shared is shared between the client and the server. But as soon as you have a TS configured for your server and one for your client, each one absorbs the shared folder into its output. And so really, composite projects give you a way of, organizing these in a way that, the dependency structure just sort of falls out naturally, and you don't have to think about rebuilding and avoiding, redundant work over and over again. So I think this is kind of the direction for any new project, beyond just a source folder. So I'm excited for it.
Definitely.
Cool. I think this fine young gentleman had a question about how come Modules ruin the internet or something. I heard you shout it out here a second ago. Since you're the seventh panelist, did you want to ask the question yourself?
Let's just have like a 45-minute Oxford debate about breaking the web.
Yeah. So what do you guys think we should do? Should we have good names for things, or
Bad names, only bad names.
good names for things and break the web, or slightly worse names but the web continues to work? Which is better?
That was a great question, random stranger who's never met these people.
It's completely crazy to me to, consider just saying like, oh, let's just break a bunch of these websites without any input from the people who use the websites themselves. TC39 has had a pretty good stance about this, where, the stance is basically, developers' lives are really important. Like, we want to make it easier for people to write code, but
Is this
not
a new
at the
hashtag
expense
for you?
Don't make it a hashtag. Don't quote me on that.
Don't go there.
You know it's a podcast, right?
What's that?
You know it's a podcast,
Oh,
right?
is it? Okay.
Yeah.
Interesting.
We talked about this before we started.
All right.
These people all know it's on
As
the
long as
screen.
I
You
don't-
can't see, but hey.
Okay. Yeah. So.
So would it change your view, though, about it? Like, the fact that it's Modules, I think, kind of makes everyone go like, I mean, if it was like, it's going to break jQuery, people are like, I probably shouldn't do that. But Modules are like, really? Like,
I mean,
what's my 4 sites? Like, who cares?
if that's a good point.
That's what you were saying
but,
earlier, I
like-
think. I don't.
Like you break anyone behind a firewall, and then like you basically have to explain to someone. I mean, people were kind of throwing this notion out that, oh, you should tell them to upgrade their version of Modules, and to someone who's saying like, this tool has existed for the last like 12 years, I've not touched it in all that time, and now I have to find someone to understand this and upgrade the dependency and hope nothing breaks. They will tell you to go take a long walk, in not as nice terms, right? So,
I've been on the internet.
yeah, right. You've been there. We've all been there. So yeah, I don't know. Like, clearly, I know this was like a joke question, but
Oh, it's legit. This
it's
guy,
legit?
this
Yeah.
whole time.
so I don't know. You have to. Anders alluded to this before. Nobody likes break for the sake of purity or anything like that, right? You're just making people's lives harder, and so they're perfectly better names. I'm sure Unwrap would never break anybody, right, Brian? We could look into that. Should be fine. Okay, yeah, but I don't know. Just pick a better name. Pick one in German if we need to. I don't know.
That would definitely simplify things.
Yeah, much simpler. Yeah.
Cool. I'll ask one more question. Were there any notable challenges in representing the various JavaScript module systems, CommonJS, AMD, in TypeScript?
Nothing notable, not really. No.
These ones weren't even on the list we were gonna ask, but because we had time, that's why now it's getting. You should see what's gonna happen in 20 more minutes if we keep going.
Then-
Like, it's not
then-
gonna be good.
Daniel has an Excel sheet with all the modules, the ways you export, the ways you import, and the variants. And that thing has like 8 dimensions. That thing is not
It's all about the
human
pivot
readable.
tables.
Yeah, there was basically, as we go on and try to find ways to make our lives harder, we're trying to, so I want to be very sensitive about this because I think everyone in JavaScript world wants things to work as well as possible to give people an easy time to use modules in Node, right? And that's currently something that doesn't work without a flag in Node. But there's some wish that CommonJS and ECMAScript modules would interop a little bit better. And so compilers have a strategy here, right? Babel has a strategy, TypeScript has a strategy, and in our recent release we have a new flag called ESModule interop that allows you to get a little bit closer to the Babel strategy, makes it easier to migrate between the two of them. And it also makes it a little bit easier to use the same strategy that Node has proposed right now. But that said, it's an incredibly complex scenario because if you want to think about existing tooling like Webpack, TypeScript, Babel, you want to think about Node, and you want to think about ECMAScript modules as a pure concept. Mohamed actually alluded to this. I came up with an Excel spreadsheet of here's how we could support both systems, and here's what the possibilities are if you emit it this way, but someone imports it this way, and you have to start thinking about all the cases, and you lose your mind. Which is why I am the way I am today. I like to joke that.
I still like you.
Yeah, thanks, Anders. I like to joke that I lost all my hair from thinking about the module scenario. So, yeah, there's a lot of difficulty there. Is the TLDR?
I think the elephant in the room is destructured ES6 imports from CommonJS modules.
Yeah.
Everyone loves import read file from FS with curlies around it, and there's a lot of I think the last proposal would not support that.
Correct.
And it's going to be pretty painful if we have to spend the rest of our lives saying, well, TypeScript 4.0 was a big semver break because we broke every single destructured ES6 CommonJS import in the world.
Right.
So I hope by hook or by crook we don't end up there, but it's still in flux.
Yeah, and there is this old style import and export syntax that actually was made to reflect the way that you do create a CommonJS module or an AMD module, and to be honest, that is actually the best source of truth in a lot of these cases, right? A lot of people say, well, it's not standard, but in reality, you're being more true to the implementation itself. So indefinitely typed, for instance, we now tell people use export equals if you were using a CommonJS module in a lot of cases.
I mean, I think a lot of the pain started with a couple of things, right? I mean, by the time ES6 modules rolled around, there was actually already established practices for modules called require.js and common.js that people were using, and the committee chose to do something different, which is quite unfortunate. And then the committee further chose to not actually specify the runtime semantics of modules, right? And so we were left with syntax but it wasn't exactly clear what it was supposed to mean and how it was supposed to map onto the existing module systems. And by the way, it wasn't the same as them either. Yeah. And that is a prescription for pain, and now the pain has arrived.
Yes.
But we'll get there. I mean, we'll find it. We'll all, yeah, and we can flag our way out of it. I mean, we'll
Just to make sure we hit on every controversial topic in JavaScript, can we expect .mts files?
I'm not even going to go there. I want to see the MJS files really make it first, But then, who knows?
That's
who
a
knows?
great.
Then we'll need MTSX. It'll be great.
Yes.
All right. Okay, random heckler number 4. All right, well, that's going to do it for this episode of the TalkScript podcast that you didn't know you were a part of. So I appreciate you being here. I don't know if that would have changed things. Maybe earlier on you'd have realized you'd be like, I'm not doing this. I'd have had a chair to sit on, I guess. I don't know. But thank you guys so much, and thanks everyone for listening. And of course, I would say subscribe. I know you already do, so it's fine. And I'm just going to turn it back over to Nick here, and you guys are free to run away if you want. I don't know. Maybe give these guys a round of applause.
Yeah, let's give them a big round of applause. Good night.